morning students, welcome back to online class. Today we are going to discuss the continuation of the third unit, buoyancy. We already saw that a body experiences an upward force due to the fluid surrounding when it is partially or fully immersed into it. We also know that a pressure is more at the bottom. So here pressure is more, isn't it? And less at the top of the liquid. So here the top of the liquid, the pressure is low. So this pressure difference causes a force on the object and pushes it upward. This force is called buoyant force. So what about the direction of the buoyant force? It is an upward force. So this force is called buoyant force and the phenomenon is called buoyancy. Most buoyant objects are those with a relatively high volume and low density. If the object weighs less than the amount of water it has displaced. So let us consider the object weight is very low compared than the amount of water. It's filled inside the vessel. Okay, so here the density is low. So what about the density? The density is low. So what about the buoyant force? The buoyant force will be increases. So what is the relation between the density and the buoyant force? Both are inversely proportional to each other. The density is less, the buoyant force will be more. So what about the object? The object will float. Such object is known as positively buoyant. This is known as what? Positively buoyant. So what is the condition? The positive buoyant means the density is low. Now the buoyant force is more. So the object will float. What about the object? The object will float. So this only is called as the positively buoyant. Okay. Suppose you have to consider as if the object weighs more than the amount of water. So we have to consider as what? The object weight is needed. So this we have to consider as object weight. The object weight is more compared than the water. Now what about the density? The density is also is more, is needed. What about the buoyant force? Both are inversely proportional to each other. No, the buoyant force will be low, isn't it? So the density is more, the buoyant force is less. So what about the object portion? The object will sink. Okay, because the density is high, no? So automatically the object will sink. So such object is known as negatively buoyant. Is called as which one? Negatively buoyant. I hope you can understand. So first we have discussed what is buoyant force and what is buoyancy. And second we have discussed what are positively buoyant and what are negatively buoyant. I hope you can understand. Okay, now let us see a Cartesian diver. A Cartesian diver is an experiment that demonstrates the principle of buoyancy. So let us see the construction of the Cartesian diver. It is a pen cap with clay. The Cartesian diver contains just enough liquid that it barely floats in a path of the liquid. See here. Okay. So its remaining volume is filled with air. When pressing the path, see the figure also, when pressing the path, otherwise we have to take it as a bottle, the additional water enters the diver, thus increasing the average density of the diver. So after automatically the Cartesian diver, it sinks. Okay, because the density is increases, no? That's why. Okay. Now let us see Archimedes principle. It is an important principle, Archimedes principle. Archimedes principle is the consequence of Pascal's law. Already we have discussed Pascal's law, isn't it? According to legend, Archimedes devised the principle of the hydrostatic balance after he noticed his own apparent loss in weight while sitting in his bath. Okay, so here the story goes that he was so enthused with his discovery that he jumped out of his bath and ran through the town shouting Eureka. So he heard this word now, Eureka, isn't it? So the Archimedes principle states that a body immersed in a fluid experiences a vertical upward buoyant force. So your body is immersed in a fluid. So it experiences which one? Buoyant force. What is buoyant force? It's an upward force, isn't it? So the upward buoyant force, this force is equal to weight of the fluid it displaces, because the object is immersed, no? That's why. So the vertical upward buoyant force is equal to which one? The weight of the fluid it displaces. So this statement is the Archimedes principle. Okay. When a body is partially or completely immersed in a fluid at rest, it experiences an upthrust, which is equal to weight of the fluid displaced by it. So due to the upthrust acting on the body, it apparently loses a part of its weight. An apparent loss of the weight is equal to the upthrust. So the upthrust we can able to find out, is it? So for a body either partially or completely immersed in a fluid, upthrust equal to, we can write the formula, upthrust equal to weight of the fluid displaced. So what is the upthrust here? Upthrust is nothing but it is a what? Force is needed. So the upthrust equal to weight of the fluid displaced. So this weight of the fluid displayed will be is equal to apparent loss of weight of the body. Apparent loss of weight of the body. So next we can find out what is the apparent weight of an object. So the apparent weight of an object is equal to true weight of an object in air minus upthrust. What is upthrust here? The weight of water displaced. So we can find out what is the apparent weight of an object also. I hope you can understand. Now let us move on to the important 2-mark question. Laws of flotation. Already we have discussed what is float and what thing is needed. So based on the flotations only we can explain the relation between the density and the buoyant force is needed. So the laws of flotation are the weight of a floating body. The weight of a floating body in a fluid is equal to the weight of the fluid displaced by the body. So according to the Archimedes principle is said. So the weight of the floating body in a fluid is equal to which one? Weight of the fluid displaced by the body. And second one, the center of gravity of the floating body and the center of buoyancy are in the same vertical line. And see the diagram also. See here, this is the downward directions. What? This is given as the buoyancy, and this is we have to take as the center of the gravity. Based on the center of the gravity only, we have to explain this one. Isn't it? So the center of gravity of the floating body and the center of buoyancy are in the same vertical line. So this is the vertical line. So both are the laws of flotation. It's an important 2-mark question. So the point through which the force of buoyancy is supposed to act is known as center of buoyancy. Where it has to act is known as the center of the buoyancy point. So the point through which the force of buoyancy is supposed to act is known as center of buoyancy. So this point only we have to call this which one? Center of buoyancy. I hope you can understand. Thank you, students.